So, a very good afternoon to all the students of CSC 1, 2, and 3, sixth semester. So, the topic of the day 2 is obtaining the required tools, Android software development kit, installing the tools, and then what are the various Android development tools, and how will you create a virtual device onto your systems. This will be your PPT, which will move on. These are the contents which we will be doing. First is Android Android development tools, obtaining the required tools, SDK manager, Android runtime, steps to create the ABD, and the types of Android apps that we'll be using on our Android platform. So first is Android development tools. So whenever you install the Android on your systems, it comes with two types of tools which are inbuilt. One is SDK tools, another is platform tools. SDK stands for Software Development Kit, which is actually required to build the Android applications. And secondly, we need platform tools. Platform tools are the tools where we can deploy our Android applications. So there are many softwares where you can deploy your deploy your Android applications like Fabric, Android Studio, IntelliJ, kind of environments are there. Even NetBeans, you can install your Android applications. So what are SDK tools? SDK tools are generally platform independent. Platform independent means that they are free of the operating system constraints on whichever they are being installed. Means you can install it on Linux, you can install it on the Windows, or you can install it on Mac as per your wish. No matter which Android platform you are working on, whenever you will install Android SDK into the system, these tools automatically get installed. That means whenever the installation takes place, in the last window, we can have the SDK tools installation. By default, it is this library is fetched whenever you are installing. It is fetched from the net automatically. Normally, the latest version of SDK is fetched. I told you the different versions of Android in the previous lecture where you have mentioned the API levels. API is application programming interface levels. So the latest version which is going on in the market is 32. So 32 version will be installed on your system. It consists of the complete set of development and debugging tools. Development means you will develop the Android app. Debugging means you will compile and will look for the errors. So the ADB is there, Android debugging tool is there, which will tell you what kind of errors are there and how will you rectify it. And finally, after rectification, you can run your Android code. So SDK developer tools are of three types. One is SDK build tools, then is Android emulator, then third is SDK platform tools. I'll show you this in the Android Studio after giving the details of these all. So first is Android SDK build tools. It is actually used for building the binaries of Android app. We know that every Android code has to be converted into the binary code before it has to be compiled. So build tools are there which will actually convert the Android code into the binary code. Then it will be passed on to the compiler for the building. Here, actually compiling of application is called building. So build tools are required for completely building the application, that is compiling the application. Then you will debug them and run them and test your Android applications on the emulator part. So while downloading or updating Android Studio, one must ensure that its latest version should be there. That means in SDK components, we should look for the latest version. Now, how will we check in the Android Studio? I'll tell you. Then what is Android emulator? Android emulator is nothing but a simulated Android device on your system. If you will install it, then you will get the copy. That means you can have the emulator in your Android app itself. And if you will not install it, you can use the USB teething and plugging in the C-type cable into your phones, and you can directly deploy your app onto your mobile. So this is how Android emulator works. Then we have Android SDK platform tools. This is very, very important because whenever we are working on the project, then the project will give some errors. Then it is specifically SDK platform tools are specifically used for testing. Then you can use them using the command line tool that is called Android Debug Bridge. which helps us to communicate with the device. That means in the build window, we have some actions which need to be performed. And after performing those actions, we can rectify our app and we can run it. Then we have one program which is called fast boot. It allows you to flash a device with the new system image. I'll tell you what is system image. Then system trace tools helps you to collect and inspect the timing information. That means whenever you are running running an app, for example, your app encounters some error. After some time, you recompile it and again launch that app onto your phones. Then the previous version of the app should be deleted in order to get the new version. So that previous version is deleted. So there the time plays an important role. Suppose first library you have deployed at say 12:45, and after getting the errors, next library you have next app you have deployed at 12:55. That means your 12:55 app is the latest version. So it should replace the previous version of the app which was installed at 12:45. So that is done by system trace tool. Now, SDK tools is a component. It consists of the set of tools which and other utilities which are crucial for the development of Android application. Means it is a bundle of tools which is actually used for the development of the Android applications. So it contains the complete set of debugging and development tools. So it contains the complete set of debugging and development tools. So I'll show you the where you have to go. We have to go to tools, and there is called one component which is called SDK manager. Actually, this component is responsible for giving us all three of them, that is SDK platforms, SDK tools, and SDK updates. If you are able to see on your screen, there are three tabs. One is SDK platform, second is SDK tools, and third is SDK updates. So first of all, we'll see how to install the SDK. Suppose if you have missed your library of SDK while installation, then you can come to this SDK platform. And if I select supposingly, because I have already installed API 32 and API 31, that is Android API for 13, then we have this Snowcone Android 12.0 have been installed. Now you can install this 11.0 for Red Velvet. So see, it is written not installed. If I say OK, then it will ask me this message. The following components will be installed. 30 with revision 3 means some changes have been made to the API level 30. So I'll say OK, and it will start downloading. See, it is downloading very quickly. So it is going on. So I'm just waiting for it to finish. When we'll finish it, it will say me it is installed. You can install as many SDK you can. That means, but it is always recommended to install the latest SDK. It will take some time, so I'm going to cancel it down. See where we have to go. We have to go to tools, then we have to go to SDK manager, and see this status will be changed from not installed to installed. Fine. Then you have SDK tools. I already told you there are three types of SDK tools. One is Android SDK build tools. So they are installed. They will be installed automatically when you will install the API from the SDK platform part. If I install this Android 12.0, then I will get three packages. One is Android SDK build tools. Second, I will get Android emulator. And third, I will get SDK platform tools. And the status here will be installed. From here, you can check whether three of them has been installed or not. So here we can check them. And SDK update sites, you can check any of this, and they are already updated, because whenever you connect to the internet, these things get already updated by itself. If there is some change in SDK API 32, then it will be automatically updated. You need not to give these updates. So this is how SDK manager works. Actually, SDK manager is the component which is responsible for installation of Android APIs, then for SDK tools, and then for SDK updates. Fine. So their SDK obtaining the required tools, whatever the Android SDK the first and most important piece of software you need to download is Android SDK. I already told you. Then the Android SDK includes the following. First, it will have some APIs, which is a set of core libraries which help the developer to develop the Android app. So next is your development tool. To turn the source code into the executable file, the SDK includes several development tools that let you compile and debug your application. That means here you will have the components which will help you to develop your app, and after developing, the source code needs to be converted to the executable Android app, and that will be installed on your phone. And before installing on your phone, it will let you to compile and debug your applications. Next, it is having Android emulator. I'll show you what is emulator. The Android emulator is fully interactive Android device featuring several alternating skins. Using the emulator, you can see how your application will look and behave on the Android device. So it is just copy of your phone, which will be there into your Android app. And you can see how it behaves like your original phone. Then it contains full documentation and some sample source code is there. Some application demonstration is there, which comes inbuilt with the Android Studio. Then you have the online support. You can contact this website http://code.google.com if you have certain issues in developing the Android app. So these are the core libraries I've mentioned in the first part, that Android APIs. These are the Android APIs which are there, which helps you to develop your application. These are the core APIs available. First is Android.OS. OS stands for operating system. It provides the package. This is a package which provides the access to the basic operating system services. Basic operating system services are clock functions, your message passing, inter-process communication, memory management, processor management, and debugging. These are all the functions which are being facilitated by Android.OS. Then graphics. So graphic libraries, you want to use graphic in your apps, like you want to use different color, different canvases, different drawings. So that will be supported by this Android.graphics. Then text, you use the different fonts of the text. So this is a processing tools for displaying and parsing of the text. Then Android.database, it gives you the cursors when working with the database. Cursor is nothing but a temporary area where you store the results of your query. Then these results of the query are fetched and they are displayed in the different boxes or different containers. So Android.content, the content API is used to manage the data sets, publishing by providing the services while dealing with the resources, content provider, and the packages. Now let's have the look of what is Android content provider. See, this is the content provider. Suppose you want to search something like something from your contact list. So your content provider is your contact list. It will search for the required content. That means it will look for the databases, files, SQLite, internet, whatever the content you are looking for, and it will provide you on the single box. So you can look for the images, you can look for the videos, you can look for the local searches, anything you will see that YouTube is your container. I show you how this container works. See, this is the contact list, and we have stored their data in the cursor form. So this is the temporary area where the data is being stored. Then whenever you are looking for any information, suppose I want to look for the phone number of Ajay. So what happens? You will press Ajay. Ajay's data will be fetched from the cursor, and it will be sent by the content resolver to the container itself. So this is the window where your names are being displayed. This is a window where the content resolver will give you the entire information. See, whenever you are pressing any contact button, then you get the entire information about that person. So that is given into this screen. This is your content screen. So this is called content provider. Next, you have different views. That means you use different views to develop your app. So this entire screen is called one activity. This entire screen is called one activity, where this name is called text view. And here Ramkumar is your edit text view button. This form get, mail get are your radio buttons. These form get and mail get are your check view buttons. Here it is the date picker. Then where the Android pictures are pasted, these are your image view buttons. Then this is your button, right? So these are the components which we'll be using to develop a particular app. So these are the core components. So now Android.views. I told you what are the views. Views are the core user interface class, or the user elements are constructed using a series of views to provide the user interaction components. So as you can see in the previous view, this is a series of views which is given to the user to experience the UI interface or UI view. So this is complete set of views. Then you have widgets. I showed you the widgets built on the view packages. The widgets are the classes, user interfaces, which helps you to frequently run your application on the home screen. So next is to get the map onto your screens. We use the library com.google.android.map. It helps you to navigate the maps, or it helps you to access the map throughout your application. Then you have Android.app. This package is basically used to collect all the activities from your application and the services which you are using, and then make it a single app. So Android.app is responsible for collecting all the activities and services which you have built in your Android application. Next, Android.telephony. If you want to use services which are related to telephone, like you want to make some calls, receive some calls, phone status, or SMS some messages, then we use this library that is called telephony. Then you have Android.webkit. The WebKit package features the API for working with web-based content. That means you can embed your website into your web view for browsing the website into your phone browsers. And it will also have the cookies part, which are already there in the website, which are being launched on the internet itself. Next component is SDK Manager. As we have seen in the Android Studio, there is one component called SDK Manager. The SDK Toolkit bundle. Bundle is series of software which provides the software development kit and the emulator system from the latest platform. Latest platform means we have a latest version of SDK which is installed in our system. So, however, you will need other platforms to test your apps on the earlier versions of Android. If we want to use the earlier version of Android, that is also available in SDK. So you can get the components of each platform using the SDK Manager. It is a set of development tools used to develop the application for the Android platform. Then every time the Google releases a new version of Android, the corresponding SDK is also released, and it is also updated in the Android Studio. So if you wish to write the programs into the latest version, that means you have to download and install the latest version of SDK into your phone as well as into your laptops. Then Android Studio includes the following things. One is required libraries, debugger, emulator, the documentation part, sample source code, and tutorial. These we have already covered. Every SDK will have this. Then I told you this, you have to go to tools, then you will go to SDK Manager. There will be 3 tabs. One is SDK platform, SDK tools, and SDK updates. In SDK platform, you can install any version of SDK which you require. For example, you want to test your application for the Jelly Beans. Now here the Jelly Beans are to Android 4.3 and 4.2. Then you can go for Android 4.3 or 4.2, whatever you wish, and you can install it and you can test your application onto the emulator itself. Now, SDK tools, I told you that there are 3 tools which comes with the SDK. One is the SDK build tools, emulator, and platform. Then updation, I know that you know that updations will be done automatically. These are the SDK tools which are there. So first, it is Android. If you want to manage your AVDs, AVD is Android Virtual Device or emulators. Then projects and the installed components of SDK, they will be managed by the Android. Second component is DDMS, which lets you to debug the Android application. Then Draw 9 patch, it is used for using the graphic library into your apps. Then emulator, this emulator tool helps you to run your application or test your application without having a physical device. You can check it on the Android Studio itself. Then make SD card. If your emulator is short of memory, then you can extend the SD card storage. It will create a virtual disk image which will occupy the memory from the system, and it will be shown into the emulator itself. Then ProGuard is basically used to shrink or optimizes the code by removing the unused code. Then we have SQLite tree. It is used to access the database files and is used by the Android application. Then Traceview helps you it will give you the graphical view of the execution logs which are saved by your application. Then is Android Debug Bridge. It is a versatile command line tool that lets you to communicate with the emulator or connected Android power device. It will help you that you have connected with the Android device successfully or not. Then we have three important tools which are there. We'll discuss them one by one. First is Android. So it is a development tool which helps you to perform these tasks. First, manage the Android virtual devices. Suppose you want 3 virtual devices at a time. For example, you want to test the application on Jelly Beans, then you want to run the application on R, then you want to run the application on KitKat version. That means for 3, you need 3 virtual devices with 3 different SDKs. So AVD Manager will help you to manage all the 3 devices. Now, how it will do, I'll show you practically. Then create and update Android projects. Update your SDK with the new platform add-ons and documentation. Suppose a new version has been released or some changes has been done, then it will install the patches to the SDK so that you can have the latest SDK with all the updates. Then I told you DDMS. DDMS stands for Dalvik Debug Monitor Server, which provides many services like message formation, capturing the screenshot, exploring the threads and file system on the device. Then SQLite 3, this is a command line program which is used to manage SQLite databases which are created by the Android application. That means we can access the database from our mobile, or we can store the database onto our mobile to be used by the various Android app using the SQLite 3. Then Android runtime. Before that, I'll show you the Android part and how we will use it. See, you will go to tools, then you will go to AVD Manager. This is your Android Virtual Device Manager. Before that, I'll show you what is Android Virtual Device. So this is the application which is test. It is already made. I have not written anything. Only the text has been written. That is called Hello World. If I see its design, I'll get 2 windows on the screen. One is the white window and one is the blue window. White window is how I have created, and blue window is how it will appear on the final screen. Now, if I want to run this instance, tools, AVD Manager, see, this is a virtual device which is made by me, and it is resolution of this much. API 30 is there, and Android 11 is being installed as an image. So if I play this, see, it is written starting AVD. If you see at the bottom of your screen, it is written starting AVD. A blue line is going. Now ADB helps this app to be deployed on the Android phone. If your emulator is not working, then the ADB error will come. Android debug error will come. It will be not able to initialize the ADB. The Android Studio will not be able to initialize the ADB. See, now the phone-like screen is appearing in front of you, where you are seeing the pink background. This is called skin. These are the various icons. So you can change these skins. You can, if you want to do anything, you can do. See, if I no emulators are currently running. So just wait. See, if I am running this project over the emulator, it is written Gradle build running. That means it will see all the background tasks which is to be incorporated on this Android virtual device. So it is coming in few seconds. Before that is coming, I'll show you other things here. If I see build, see this is my build log. The build tools tell me how where the compilation part. If you see the left hand side window, it is written build. So it is telling me the execution part. Fine. So here I'm getting command line connections. That is DDMS is giving me command line. If some error will appear. See, it is there. We recommend to use SDK32, which is the recent version. But the build will continue because I have already installed API 30, so that does not matter. If any error will be there, then it will come in this right hand side window, which is printing the messages in red color. See, scanning the files to index. So when this message is coming, then means your module will be launched. See, run part and launch succeeded. So we'll see where it is coming. See, this test application has been deployed with hello world message, right? So this is how it is done. Logcat will give you me the error logs if it is there. So since there are various processes which have been carried out while installing this app, so these all will be shown in Logcat. Then if you'll be able to run window, then it will give you the application has been launched successfully. Build window will be used for the compilation part. This is how it is done. Right? If I want to add image, one more image, I'll tell you how to add. Go to MVD Manager. So you will click on create virtual device. Then you will check any phone you want, which is to be displayed instead of this. So I've selected Pixel 6.0. So next, I'll do next. Then you can download the API for the image. That emulator will consist of R operating system, Q operating system, that is up to you. So R I have already installed, so I can have Q and Q will start downloading. See, the repositories have been fetched. Now it will take some time. So you can install the operating system Q in this way, but I am canceling it out because it will take time. You can do it of your own. Then you can choose the same R operating system. Same image can be used for 2 or more virtual devices. See, next, I will put this name as CSC6. Fine. So this will be the name of AVD. So you want this orientation as portrait or landscape. This is up to you. You can select this. Either you can select the portrait. Rest the things will remain same. If I say finish, see a new virtual device has been created in front of you. As you can see, we have now 2 devices. So there are multiple VMs which will be running. The size on the disk for first is 9.2 and second is 513 MB. Why there is a difference of size? Because the SDK has been downloaded for this first version, and later on his copy is used here. So if I just play it, I'm just playing it. See, it is giving me the message starting AVD. Now you see the device which will come in front of you. What we have is run multiple VMs efficiently. Each app has its own VM. Minimum memory is required. Actually, we have a very small space in our mobiles. So we can install our app in small amount of memory. For that, the Dalvik runtime environment was introduced with the Android so that we can launch our apps on the platform itself with small memory requirements. Then next, Android software stack, Dalvik, just like JVM in Java, we have Dalvik virtual machine in Android. What does that do? It takes our Java file because the primary code of the Android is written in Java. Then it is compiled to class file by the Java compiler. Then the Dalvik executable compiler makes this class file into the DEX file. Fine. So Dex, why it is converted? Because class file which will be converted by the Java compiler will take much more memory than the Dex compiler. So Dex format or Dalvik executable format is optimized for minimal memory requirements, so that you can compile it with the minimal memory and will deploy onto your mobiles. Then this is the flowchart. Write the app in Java, compile in Java using JavaC, then transform into the Dalvik bytecode. That Dalvik bytecode will be loaded to the Dalvik virtual machine and its entire kernel will be in Linux. So it will be able to execute your code. So this is the short flow chart where Java file is a source file of activity. Then it is going to Java compiler. Then it will make the class file. And the DEX compiler will convert it into the Dalvik executable file. Then AAPT package, that is Android Asset Packaging Toolkit, is the package which is responsible for converting all the DEX files into a single app. That means it will club all the files into a single app. So here you can see that so here you can see here is Java file. It is converted to the compiled class file using the JavaC compiler. Then DEX compiler takes all your class files of your project and convert it into single Dalvik executable file. Then Android Asset Packaging Toolkit is responsible for converting your DEX file into the APA file, which can be deployed on your mobile phone. So here are the steps. The DEX compiler converts the class file into single DEX file that run on the Dalvik virtual machine. Multiple class files are converted to single DEX file. Then let us see the compiling process. JavaC tools compiles the Java source code file into the class files, and DX tools takes all the class files of your applications and generate the single DEX file. So this is platform specific. And Android Asset Packaging tool handles the packaging process and converts it into the single APK file. Next, actually, what happened? It was before KitKat version that Dalvik virtual machine was going for, and it was using just-in-time compilation. That means whenever we need to install the app on our phone, only at that particular time the compilation and installation process takes place, and it took a lot of time, but it was called just-in-time compiler. And after KitKat, there was one thing which was being introduced was AOT, ahead of time. That means compilation was done beforehand, before installing the app. Once the build part is over, then we can have the installation part. So the compilation was done before the installation. So that was your ahead of time. So ART is Android runtime. It was the layer which you have seen in the Android architecture. It is used by applications and some services on the Android. It is the ART and its predecessor Dalvik were originally created specifically for the Android projects. ART as the runtime executes the Dalvik executable format and DEX bytecode specification. ART also follows the same process, but just difference is this, that it does the compilation beforehand and later on the installation part. Whereas Dalvik virtual machine was used to use just in time. That means the compilation and interpretation was done while installing the app onto the phone itself. Then ART and Dalvik are compatible running times, running text bytecode. So the apps developed for the Dalvik should work when working with ART. So the apps which were developed before the KitKat version or on the Jelly phones, they can be used on today's phones also, because ART is backward compatible also. So it is there, ART features. It is ahead of time compilation. That means we can improve the app performance, as we have already removed the bugs from the code, and we have installed. It will take smaller installation time, because earlier when both processes need to be done, it takes a lot of time. Now small time takes place in order to run the app onto the machines. So it has a good garbage collection procedure. 1+1 GC pause instead of 2. There are 2 GC garbage collectors are there. Parallel processing can take place, and this garbage collection takes lot smaller time. Then compacting GC, that means garbage collection is reduced for using the background memory usage and fragmentation. So this was your ART. AVD I've shown you, it has hardware profile, it has skins, then it has system image. I told you which operating system was there. Then it has the storage area, so that you can install your apps onto the virtual device. So these are the steps to create. This we have discussed. Tools, then AVD manager. Then you have create the virtual device. First screen while you'll be creating the virtual device for the very first time. Then you will select the phone of inches, whichever the screen inches you want, screen size. You can select 6 inches, 5 inches, or 5.8 inches. Then you can have the image download. See, I have installed the R, but before that you have to select this R, and then image started downloading. So this is the progress, and finally it is done. Then you will press next. You will select the AVD name. You can put any AVD name. Then you can have this phone you can change, and the operating system you can change. If you have other operating system, you can install it here. Then when you will say finish, then you will get this device into your AVD manager. Then we can see the phone, that is emulated device, which is connected to my app itself. Now my app, when I have run this app, it was installed on the phone itself. This was how AVD manager was created. These were the steps. So there are basically 3 types of apps which I used, and these are your mobile app, native app, and hybrid app. Native apps are the apps which are already there, which are pre-installed in your mobile phone before you take your phone. Whenever you buy a new phone, some set of apps are installed. So they are your native apps. Whenever you use the web application of any mobile application of any web app or any website, suppose we have college website as AGC Amritsar, we have app for it, which is available on the Play Store. So that is called mobile web app. And hybrid app is combination of any 2 apps. So these are the types of apps. So first is mobile app. Web apps are not real application. They are actually the websites which open in your smartphones with the help of a web browser. For example, Tutorials Point. So they have the broadest audience of all the primary types of applications. So what are the benefits? They are easy to assess, easy to develop, because you will just make the website and put it into the framework of app, and it will be deployed. Then you have easy updates as you update your website, so as you update your app. So no installation is required. So downside means what are the drawbacks? Mobile websites cannot use some of the features, that is local access to the file system or resources is not available. Some existing apps do not support the offline capabilities. Then users won't have the app icon on their home screen as a constant reminder. So they need to be open in the web browser only. While native and hybrid app appear in the App Store or Google Play Store. So redistribution is not there for the mobile apps, web apps. Then native app. A native app which is defined for the specific platform, for example, Google Play Store or iOS, that is Apple phone store. So WhatsApp, Facebook, these are your native app. So native app are live on the device and are accessed throughout the icons on the device home screen, because you cannot create WhatsApp. You have to use the inbuilt WhatsApp which is already there. So they can use the full advantage of the device features. They can use your camera, your local resources like contact list, accelerometer, compass, etc. So they can also use the device notification and can work offline. Publisher can use the use of push notification. Publisher is the person who actually deploy the app onto your phones. So he can give you the option for the push notification every time a new piece come. For example, you are getting the message on the WhatsApp, it is coming onto your notification part. So they maintain the UI part so that user can have the best experience. Redistribution is easy as these apps are found in the App Store. Then downside, it bears a high cost for building the app, even though you might publish the native apps, but you will want to keep the mobile website well maintained, and mobile brings more traffic, so maintenance is naturally higher. If higher traffic site is there, then maintenance cost will naturally be high. Then we have the hybrid apps. These are the way to expose the content from existing website in the app format. That means existing website data can be in the app format, so just as Wikipedia. So developing a hybrid app is cheaper than developing a native app, and it can be used in cross platforms for reduction of the cost of the app development. Maintenance is simple. It can take advantage of few features available in the device, can be found in the App Store, so that distribution can be easy. It has a browser which is embedded in the apps only. Then graphics are less customized with the operating system as compared to the native apps, and they are normally slower. So this was all about today's lecture. So thank you so much for the patient listening. If you have any queries or any questions, you can WhatsApp me or ask me personally. Thank you so much.